Hi guys, welcome again to my YouTube channel. And I remember in the previous video I introduced you to these three quantities. So one of the quantities that I introduced you to was current, 2 was voltage, and 3 was resistance. So in today's video we're going to discuss about the Ohm's law. So Ohm's law basically relates these three in a mathematical way. Now before we dive into the Ohm's law, I want us to understand a certain concept, just a small concept. So now let us say, for example, you have three quantities. Let's say you have A, you also have B, and you have C. Now these are the three quantities that you have, okay? And then the mathematical form of these three quantities is like A is equals to B, for example. So we haven't included C in here. So what does this mean? If A is equals to B, because they're all in the same level like this, then it means that if you increase this A, so B will also increase. If you decrease A, then B will also decrease. So this phenomenon is known as A is directly proportional to B because they're on the same level. If let's say, for example, you have C is equals to D, or E is equals to F, then it means that if you increase this one, then you'll also increase this one. If you increase this one, then you'll also increase this one. Because you cannot say 5 is equals to 6. It's not possible, right? Because if you increase this 5 to, let's say, 10, like this, then it means that it needs to be equal to 10. So if you increase this variable, then this one also should increase if they are on the same level. Now let us look at another scenario whereby you're given a situation whereby you're told that A is equals to B all over C. Now we always say that A is directly proportional to B but inversely proportional to C. Now what's the meaning of that? This one means that if you increase A, then you will increase B, but now you will be decreasing C. Because if A is equals to B all over C, now let us ignore this B first. It means that if you increase this A, then you are decreasing C because it is not in the same level like this one. Do you know this one is in the same level, but this one is not in the same level. This one is on the top, this one is on the bottom. So this one is inversely proportional to this one. Okay, so in that case, if you increase A, then in turn you will be decreasing C. But because this one is directly this and this, then if you increase this A, then you'll be increasing B. Now let us go back to our three quantities, taking note of what we have just discussed right now. So in our previous class, we said that current is basically the rate of flow of charges, and its SI unit is always in amperes, so it is measured in amps. Voltage, we say that it is the potential difference between 2 points, and its SI unit is in voltage. So we may always measure voltage in volts. So its SI unit is in volts. Resistance, we said that it is the opposition of flow of charges, and its SI unit is in ohms. So ohms is written like that, the word omega. So it's ohms. Now, what is the relationship between these three? The mathematical relationship between these three is known as the Ohm's law, whereby we always say that voltage is equals to current multiplied by the resistance. You know, the most cool thing about physics is that if you are told to define any quantity, then you can just define it just from the formula that you have. For instance, if you are told to define Ohm's law, then you'll basically say that Ohm's law states that voltage is directly proportional to current and resistance, because we've said that if they're on the same level, then it means that it's directly proportional. Because remember that example I gave you here where we said A is equals to B. It means that A is directly proportional to B because they're on the same level. So if you increase A, then you will also increase B. If you decrease A, then you also decrease B because they are directly proportional. Now from this formula of Ohm's law, we've seen that V is equals to IR, whereby in other words, it's like voltage is equals to current multiplied by the resistance. Now, let us say, for example, you are asked to plot a graph of voltage against current. What do you think that graph will look like? What will be the nature of the graph? Now, if you're told to plot a graph of voltage against current, let us just sketch the graph. So this is voltage and this is current. Now, if you're told to plot a graph of voltage against current, what do you think will be the nature of the graph? Now, let us predict the nature of the graph here. Now, we all know the equation of a line is given by y is equal to mx plus c, right? This one is an equation of a straight line. So whereby this y represents the value on the y-axis, and then this m represents the gradient, this x represents the values on the x-axis, and this c represents the y-intercept. Now let me give you an example of a graph. Let's say, for example, you have a graph that looks like this. So this one, let's say this is the y-axis and this one is the x-axis. So these values on the y-axis are represented by this. So these values are this. Okay. And then the gradient of the graph is just the change in y over the change in x. So for you to find this m, then it's just the change of y over the change in x. That is the gradient. Now this x, the x-axis, these are the values on the x-axis. Okay. The y-intercept, this c here, the y-intercept is the value that is right here, where this line cuts at the y-axis. Now we always say that y-axis, the y-intercept, x is equal to 0. So at the place where this graph cuts, the y-axis is referred to as the y-intercept. So for example, if this one is, let's say, -1, then the c here, the value of c will be -1. This one represents the y-axis, this one represents the x-axis, this one represents the gradient, and this one represents the y-intercept. Now let us say, for example, you are told to plot a graph of voltage against current. From this knowledge, you can predict the nature of that graph. Now let us predict the nature of that graph together. Let us just use this space here. So we know that voltage is equal to current multiplied by resistance, right? Now remember, because we do not have an addition here, so it will be like plus 0. So our y-intercept is equal to 0. Now from the knowledge of this, then you can directly say that the graph will not cut the y-axis at all. So meaning the graph will originate from the origin. If the equation will be like voltage is equals to current multiplied by the resistance, let's say -1, then this will be the nature of the graph, because this -1 represents the y-intercept, where this line cuts the y-axis. But because there's no value here, it is just empty, like v is equals to ir. These two values here stands for this part here of the nature of the graph. It stands for this part here, the whole part, this whole part. But now this one, because we do not have anything here, and these ones, this 0 will represent this value here. So because we do not have a c or a y-intercept, then this will just be the nature of the graph. So the nature of the graph will be a straight line originating from the origin. So our graph will start from this point going outside that. This will be the nature of the graph of voltage against current. Now let us say, for example, you are asked to plot a graph of current against voltage. So you are told to plot a graph of current against voltage. So the graph will look like this. So the y-axis should be current, because it is current against. Against is always on the x-axis. If you're told against something, then that against, the word that a quantity that comes after against is always found in the x-axis. So it's current, which is on the y-axis, against voltage, which is on the x-axis. So if you are told to plot a graph of this kind, how are you supposed to know the nature of the graph? Now let us use the previous formula that we used. So we all know that the equation of a straight line is given by y is equal to mx plus c, right? Now said that this y represents the values on the y-axis. This x represents the value on the x-axis. This c represents the y-intercept. Now we need to put our equation into this form. The Ohms law equation is given by voltage is equals to current multiplied by the resistance. But now voltage is not in the y-axis, right? Voltage is actually in the x-axis, this one. So we need to put our equation in this form, whereby the y-axis is current. Now for us to put current in this side, we need to take this current on this side. So if you want to take current on this side, it will be like, let us just take out this resistance so that current remains the same. So this one goes, and then our current will be equal to voltage divided by the resistance. So this is the equation that we have, because this is the graph that we have just made. Now let us relate this equation to this. So our y-axis is current, so it is correct. Our x-axis is voltage, so it is correct. We do not have a y-intercept here, which is 0, so our graph should originate from the origin like this. That is correct. Now, what do you think our gradient will be? If you look at our graph, our equation here, whereby we've said that current is equals to voltage divided by resistance. So voltage here is our x-axis value. Now the remaining value, which is 1 all over r, is our gradient, because already this one is a value on the x-axis. So our gradient will be, so gradient will be equal to 1 divided by r. And this is our gradient, and this is the nature of the graph. So this is how we normally predict the nature of the graph, even before plotting the graph and doing all the practicals. And it's good to predict the nature of the graph even before starting your practicals. So having a knowledge on how to predict the nature of graph using this equation of a straight line will be very helpful for you in all practicals that you will undertake in physics and even other subjects. So that is all about Ohm's law. Until the next class, bye for now.